All right, for this bell work, just some fraction addition on this one. So 2/3 plus 6/3. Nice thing about this, it's already set up with the denominators being the same. So we don't have to worry about forcing those to be the same. And since that's the case, I can just take the two numerators, 2 and 6, and just add them together. So still in thirds, because it's not changing the size of the pieces, just how many there are. 2 plus 6 is 8. 8/3. No need to change this into a mixed number because it's not considered fully simplified as a mixed number. It's just a different format, and improper fraction will be okay for the format. Here's our objective for the day. Two objectives. I can use the order of operations to evaluate expressions, and also I can replace letters with numbers and evaluate too. Take 1 minute and copy these down, please. So it's likely that you guys have seen the order of operations before, but there's kind of a kicker to it. And then the second objective here is just, are you able to use the order of operations, because they're going to give us the values to replace the letters with when they give us letters in the expression. So that shouldn't be too bad. But before we get into that, we need to understand a little bit about what is called absolute values. So absolute values, this is the symbols for absolute values. If I saw, as a math person, if I just saw these just kind of floating around like this, while that may look like 11, if I saw anything between that, like a 3 right there, then it would read as the absolute value of 3. Okay, and any math person would understand that that reads the absolute value of 3. Okay, now what does that mean? Well, that's kind of the important part that we need to get into, but what the heck? There we go. All right. So an absolute value is just the distance a number is from 0. That's all it is. So when you see something like this, it's only asking you how far away is 3 from 0. And then hopefully you would know that that number right there, 3, is 3 away from 0. Okay, now the direction doesn't matter, because you could say even negative values. How far away negatives from 0 is still a positive value, because we never talk about distances in terms of negatives. Distances are always positive, always. And if you ever, by chance, refer to distances as negatives, you can have a great career as a politician someday. But right now, we never talk about distances in terms of negatives. It's like saying, I live negative 40 miles north of here. Well, we wouldn't talk like that unless, we wanted to trick people for some reason. But what we would say is that I live 40 miles south of here. That's a whole different, it's a more direct statement. And so that's the way we talk. That's the way we refer to distances only as positives. But once again, absolute values are those distances from 0, which I think makes those kind of easy, right? So like this one. This would read the absolute value of 17. It asks, though, the real question it's asking is, how far is 17 from 0? And hopefully we know that 17 is 17 from 0, okay? Now let's switch that around and say, well, what if you got the absolute value of negative 17, okay? Well, that would be the same question as, how far is negative 17 from 0, okay? So notice that the value here, it's still 17 because it's a distance. So negative 17 is still 17 away. It's just, if you wanted to refer to that on a number line, which we can look at up here, there's 0. To the left is negatives, to the right is positive. Negative 17 would be here. 17 would be right here, okay? So if you wanted to, you could say 17 to the left, but it still would be 17. That's the main point. These are not opposites, because some students say, well, you took the opposite. It's a negative and a positive. No, it is not opposites. It's just always positive because it's a distance. Always, always positive. So let's look at this example right here. Again, the real question that this is asking for negative 726 is, how far is negative 726 from 0? Okay, and so if you want to see those number lines, feel free to do that. So there's positives, there's negatives. I'll put 0 there. Negative 726 would be somewhere way over here, negative 726. How far away is that from 0? Well, you'd have to go 726. You could even say that you'd go to the right. Doesn't matter. It's just that distance is 726 units. So that's actually our final answer right there. All right, now it is possible to have some operating to do within the absolute value, and that's fine. And this one technically has 2 operations, because the absolute value itself is considered an operation of its own. But we just want to focus on the inside of that absolute value, evaluating it like it were a set of parentheses. So this means we don't really do anything with absolute values right now, but we can operate with -3 minus -9. Now we don't actually subtract with negatives, so I'd use keep change on this to make it -3 plus +9. I think some of you benefit from showing this as -3 plus 9 like this. Although some of you skip this step, and that's fine as long as you do it correct. This would give me the absolute value of -3 plus 9. Now I see there's more positives here than negatives, which means the answer will be a positive. Then you just take the big number and subtract the small number. 9 minus 3 is 6. So that's how positive this will be, +6. Don't really need the positive sign. And the last thing here is the absolute value of 6, which is asking how far is 6 from 0? Well, last time I checked, 6 was 6 away from 0, and that would be my final answer. Now, order of operations work like this. You got parentheses, and we're showing 3 different sets of parentheses on this. You got the regular set of parentheses here. You got your absolute values right here, which do classify as parentheses. This line right here is not a negative sign. It's actually a fraction line right there. So that'd be like a box there. Usually a box and a box there to represent where numbers would be, or even more than just numbers, operations as well, okay? So you always look to do your parentheses first, and then you look for any exponents to perform. Now, a little quick review on exponents is you got usually a kind of a big number. We'll say, I don't know, 4, like this. And then in the top right corner of that big number is a smaller number, let's say 3, like this. Okay, exponents are repeated multiplication. I think we've talked about this before, but just in case we haven't, this would indicate that you have 3 4s, 1, 2, 3, and exponents represent repeated multiplication. So you'd multiply these out. 4 times 4 times 4, and I'll skip the math. It's just going to end up being 64 there, okay? So we can evaluate with exponents as long as we understand that exponents are repeated multiplication. Once again, that smaller number tells you how many times to multiply the bigger number by itself. And there's more vocabulary for that, but we may cover that later, okay? Now here's where we get some confusion, because some students are like, it's always multiplication and then division. Because of this piece of crap, Pemdas. And I know in elementary school, they're like, look at this funny, awesome thing, and then they give you a big hug, and they're like, oh, please excuse my dear Aunt Sally, that is horse crap. Please do not refer to this as Pemdas, otherwise you're going to screw things up really badly. Okay? Don't do it, because it's not always multiplication first. Sometimes the division comes first. See how it says or in between there? That's on purpose, by the way. It's multiplication or division. You have to scan these from left to right. Okay, so if you see that the division happens first from left to right, you have to do the division first. Which means that if you wanted to refer to it as Pemdas, sometimes it's Pedmas. See, it's not so gimmicky anymore, is it? Or addition and subtraction. It's addition or subtraction, again, from left to right. So you're scanning. If you see subtraction first, you have to do it first. If you see addition first, you got to do it first. So not only is it not always Pemdas, it could be Pedmsa. See, yeah. See how crappy that was? That's why we don't refer to this as Pemdas. Please don't, because it would also indicate that you got 1, 2, 3, 4, 5, 6 steps. There's only 4, because we're combining multiplication or division, and then addition or subtraction. Yeah, that works for me. First come, first serve. Yeah, I like it. It's good. So think about the order of operations like this. Okay, is it's kind of like a surgeon. I don't know how many of you have had surgeries or anything like that, but it's like, let's say that the surgeon is going to give you surgery, and they start cutting you open, but they haven't given you the anesthetic yet. Okay, now, yeah, that'd be really crappy, right? Because they did it out of order. You got to get the anesthetic first, and then you can start operating. It's kind of the same thing with mathematics. You guys need to be good math surgeons and do things in order. Otherwise, you're going to really jack up the problem, which we don't want you to do. We want you to do it correctly and not have injured patients at the end. Now, of course, we are practicing right now, so it's okay to make mistakes, but we don't want you to do this to make a lot of mistakes, especially when you're taking a test. Okay? The next best thing about the order of operations here is that it is a great problem-solving method. However, one other great problem-solving method is breaking big problems up into smaller, more manageable problems. So with the order of operations, it actually forces us to break big problems up into smaller, more manageable problems. Okay, and it's going to do this naturally for us. It's going to force us to do it because if we do it out of order, then we're breaking it up into in the wrong ways, which is very bad. Our first problem here is just to make sure that you have this down, because a lot of you, I think, or at least some of you, would say, look, you have to do this 24 plus 74 first. If you do that, you will get it wrong. Please do not do that. Please do not do it, because it's, of course, there's no parentheses here, right? Let's go through them. There's no parentheses, there's no exponents. In fact, there's no multiplication or division from left to right. There is only addition or subtraction, but the subtraction happens first on the left, so you will need to do the subtraction first. You need to do it first. 33 minus 24, I'll have to stack and subtract that. I know some of you can do that in your head, and that's fine. So borrowing from the 3, 13 minus 4 is 9, 2 minus 2 is 0, so that ends up being 9. Now I can add my 74 there, and 9 plus 74, let's stack that, 74 plus old 9er, 4 plus 9 is 13, carry the 1, 1 plus 7 is 8, 83, boom, I did it. Now on this one, if you did 24 plus 74 first, that's like 98 right there, so 33 minus 98, horse crap. Please don't do it, stay away from it, because it would be out of order. So yeah, if you were to do on this one 24 plus 74, it'd just be doing it out of order, you would have messed up the patient, and you would have gotten a very different answer. This one's good old-fashioned order of operations. Not too many operations. It's a good start, though. The first thing I notice here is that we do have a set of parentheses right here, okay? Now, it's been a little bit confusing because we've been doing a lot of keep, change, or keep, change, flip kind of garbage. But now it's just 6 minus 2. There's no need for keep, change on this one because it's not actually subtracting with negatives. Just 6 minus 2, which is 4. Okay, so if you can just do that directly, then do it. And then we got 3 plus 5 times 4. Okay, now, we've talked about this before, but multiplication is the only operation that does not have to be shown in certain cases. In this case, it's not being shown between the 5 and the parentheses 4. That indicates that there is multiplication there. If you want to show it, you're welcome to, like this. Okay, and now I know that there is multiplication. So evaluating this, we just did parentheses. I don't see exponents, but I do see this multiplication now that I put it there. And so that's my next step, multiplying. 5 times 4 is 20. Now I got 3 plus 20, which is 23. I did it. Now something that happens on problems like this very often. Okay, so let's look at the original problem. 3 plus 5, parentheses 6 minus 2 on this one. A very common mistake that students make on this one is 3 plus 5. Well, 3 plus 5 is 8. Now 6 minus 2, that's 4. 8 times 4 is 32. See, this is it's not like it's so different from the original answer, but it is different. And as it turns out, it's garbage. Please, it's this, and it happened here. You did there you go. You started to operate before you gave the patient some anesthetic. Or, you know, maybe the doctor forgot to put on their gloves or wash their hands before they started the surgery. That'd be pretty nasty, right? So please don't do that. Don't do this thing. You gotta keep everything in the order of operations. Again, this one is just meant to make sure that you understand that sometimes division will come before multiplication. And so, yep, just going through, there's no parentheses, there's no exponents in this problem, but there is just multiplication or division. And once again, if you did 5 times 2 right here, you've destroyed the patient, and that would be very, 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 very bad, okay? So we're gonna skip that garbage. We need to do the division first because it happens first on the left. So we'll do 30 divided by 5, which is 6. Then we can multiply by the 2. 6 times 2 is 12. That is all. If you did this out of order, you should get 3. Okay, which again, is 3 and 12 that different? No, but mathematically speaking, Mathematics is a very, very exact subject for now. And so while it remains exact, then we need things to be exact. Otherwise, we're going to really jack things up. Here's this one. Parentheses, 18 divided by 6, close parentheses, minus 12 plus 7 to the power of 2. Hey, you guys try this one out. Try this one out, then we'll go over, okay? 1 minute. Still working on this. Just keep working. Just as a quick spoiler alert, though, I got 40 on this one. Let's check, though. Let's check, okay? So, just by the order of operations, first thing we got is a set of parentheses. And we do have a set of parentheses right here. 18 divided by 6, which is 3. Okay? Now, I didn't really do anything with the rest of that problem, so I'm just going to look at this here, okay? Next up, we have the exponent of 2. And that's 7 to the power of 2, which means we'd have 2 7s, and they'd be multiplied. 7 times 7 is 49. So now we have this new expression. I forgot my plus sign there. 3 minus 12 plus 49. And from here, there's no multiplication or division. So we're moving straight into addition or subtraction from left to right. And we do need to do this subtraction first. So that's what we will do. 3 minus 12. I just keep change to make that 3 plus negative 12. So when I combine them, I see there's more negatives. And I take the big number. This will tell us how negative it is. 12 minus 3, 9. So it ends up being negative 9 plus 49. And then when I go to combine these two, negative 9 plus 49, I see there's more positives than negatives. So the answer is positive. And 49 minus 9 is 40. So that would be my answer right there. It's pretty good. Let's go through this one. We'll do this one together. And yeah, we do have some set of parentheses on this, right? So we'll start with this. I start from the left set of parentheses. A lot of students ask, does it matter? It doesn't. It does not matter which set of parentheses you start with. I just go from left to right because I'm used to scanning from left to right. So for me, I do negative 6 times 13. I know that's going to be a negative because they're opposite signs. I can't do 6 times 13 in my head. So 13 times 6. 3 times 6 is 18. Carry the 1. 6 times 1 is 6, but adding the 1, it makes that 7. So it ends up being negative 78. But this other set of parentheses as well, right? 16 divided by 8 is 2. I'll keep these in parentheses just to show where they came from. Then we'll do the divide by 2 and then minus that 2 right there. Okay? So that evaluates all the parentheses. Next up, we'd look for exponents, but I don't see any. Next up, then, I'd look for multiplication or division. And I do see one set of division right here, 78 divided by 2, negative 78 divided by 2, which means that answer will be negative. I'll have to use some long division for that, though. So 78 divided by 2. 2 will go into 7 3 times. 3 times 2 is 6. So 7 minus 6 is 1. Drop the 8 to make that 18. 2 goes into 18 9 times. That'll give us nothing remaining. So the final quotient ends up being negative 39. I still need to subtract that 2, though. And even at this point, you could take away those parentheses if you need to, if it helps. But you can keep them if it helps too. So I am subtracting now with a negative. I don't really want to do that, so I'm going to change this and keep change. So plus a negative 2, like this. And now I'm adding 2 negatives, which makes it just more negative. It's going to be more negative. So 39 plus 2. 39 plus 2, 9 plus 2 is 11, carry the 1, 1 plus 3 is 4, 41. Negative 41 appears to be the final answer on this one. It's kind of a big one, okay? So yeah, we would say, look, be careful with this one because a lot of students, they just kind of quit at the beginning of this one. We don't want that to happen. Okay, we want you to be able to work through these, and the order of operations will help you because it's going to break this big problem up into smaller, more manageable problems right away. All right, now, in working with this problem, I know that it's an order of operations problem, and remember, fractions are considered parentheses. What that means is that you have to evaluate either the numerator or denominator first. I always evaluate the numerators first and then the denominators. Doesn't matter. You can do it however you want. Okay, but staying within the order of operations. So I'm going to start with the numerator, and I see in the numerator this set of parentheses, which is also an absolute value. Now that's negative 10 plus 5. So give myself some space up there to show the work. That's a negative plus a positive, but there's more negatives there than positives. So it's going to be the absolute value of some kind of negative. Take the big number and subtract the small number. 10 minus 5 is 5. So that's how negative it is, negative 5. Now you'll notice that I didn't actually look at anything else in the fraction, only the absolute value. And I'm continuing that because now I need to evaluate the absolute value of negative 5, which is asking how far away is negative 5 from 0? It's just 5. Okay. Now I can focus on the rest of that numerator right there. So that would have been like 28 plus that absolute value of negative 5. But also then just 28 plus 5. Which, I mean, you could stack and add those if you need to, but I get 33 out of that. So the numerator now is fully simplified, completely fully simplified. Now I need to fully simplify or evaluate the denominator there. So let's go over there. And I don't have any, I do have the parentheses, but there's nothing to do on the inside. No exponents. But what I do see is just this division right there. Now that would be 10 divided by negative 3. What I'm going to do is change this into a fraction, which is then going to be just 10 divided by negative 3 like this, as a fraction, okay? In fact, I'm going to move that negative so that it's just out in the front there. So it's going to just be negative 10 thirds from that division. So negative 10 thirds. Now the rest of it was negative 4 plus that negative 10 thirds, which I now need to do. In order to do that, I will need to show negative 4 over 1 so that I can force the denominators to be the same. I know a 3 is just a multiple of 1, so I'm just going to scale it that way. I'm going to multiply the denominator by 3 in order to make the new denominator 3. But I have to multiply the negative 4 by 3 as well to make that negative 12 thirds. Now I'm still going to add this negative 10 thirds here. And now that my denominators match in thirds, I can take my numerators, negative 12 and also negative 10. I can add those together. I just need more space. So from that, I now get still in the denominator here in thirds. But negative 12 plus negative 10 is going to force that to be negative. 12 plus 10 is 22, negative 22. So I now have 33 over negative 22 as a fraction. But I don't want to see this as a fraction. See how fun this is? I want to see it as a division problem. 33 divided by negative 22 over 3. Well, remember, we don't actually multiply or divide with fractions. We only multiply. So I will change this into multiplication by reciprocating the fraction into 3 over negative 22. Doesn't really matter where that negative is. So I got 33. I'm going to make it 33 over 1 so that I can show the full fraction multiplication on this. But before I do the multiplication, I will use some cross simplification. So let's say 33 and negative 22 are both divisible by 11. 33 divided by 11 is 3. 22 divided by 11 is, well, negative 2 now. So what do I get then? Well, in the numerator, I'd have 3 times 3, which is 9. In the denominator, that's 2 times negative, 1 times negative 2, rather, which is negative 2. Okay, so you could write it like this on Canvas if you wanted to. I believe that it wants the numerator to be negative, though, so you probably want to type it in as negative 9 over 2, which typed in would be negative 9/2 in the Canvas if this was negative. But now that was a lot of work. I don't think it's hard work. It's just a lot of work because it's just covering all the stuff that we have done, not just in Unit 3 or 2, but all 3 units, Units 1, 2, and 3. So variables, the only thing you really need to know about variables is that generally speaking, at least for now, they're really considered unknown values. So there's a value that we would replace the letters with. In the future, what's going to happen is we're going to have to find those values to replace the letters with. But for now, they're going to actually give us those values. So that's what evaluating algebraic expressions is. they say, hey, we want you to replace a letter with a number. It will look something like this, like x equals 5. Okay, then wherever you see x in the expression, you replace the x with that number 5, and then you solve. It's possible from time to time they'll have more than one letter, so they could like say c is -7. Okay, then you replace all the c's with this number, and then you evaluate from there. So it's just really more order of operation stuff, but with one extra step of replacing the letters with the numbers that they will give us. Just keep in mind in the future, again, you will have to solve for the numbers yourself. Okay? And then after that, just evaluate or simplify, which is, once again, order of operations kind of stuff. Like this one. So I'm going to start on this one. I'm going to start just by rewriting the problem. All right, so there's our expression there, but I'm going to replace my x's. There's 3 x's right there, there, and there. I'm going to replace them all with -2. Now I'm going to show this as -2 in parentheses. There's a reason for that, but I'll explain more about that next time, okay? So I'm going to replace all of my letters with -2 in parentheses. In fact, one of the reasons we do that is because if it's multiplication, because right here it's not showing the multiplication between the 5 and the x, which means we should know it's multiplication. But once we see the parentheses, we should definitely know it's multiplication. If you don't put the parentheses here, it would read 5 minus 2. So don't do that, okay? We want to remember that it is multiplication. Now it's just a regular order of operations problem. So I see that I've got this, well, there's nothing to do it in the parentheses, but I do see the exponent of 2 right there. So that's all I will evaluate for now. So that would be the same as -2 twice being multiplied. -2 times -2, which is going to be +4 because of the 2 negatives right there. Okay, nothing else really changed there in the numerator. So this is what we got. And again, notice I'm not putting anything else in the denominator because I don't really care about the denominator right now. I only care about the numerator. Now, we're gonna simplify. This is 5 times -2. Right there, 5 times -2. There's multiplication. There's no other multiplication or division. That would be -10. So I got 4 plus -10 plus 8. And there's only addition and subtraction, really only addition, from left to right. So let's evaluate that then, starting with, well, 4 plus -10. There's more negatives here than positives, so it is negative. And then 10 minus 4 is 6. That'd be -6. Now plus 8. And to fully simplify this, -6 plus 8. There's more positives here than negatives, and then 8 minus 6, which is 2. So I end up with +2 there in the numerator. And yeah, we just end up with that -2 in the denominator pretty much everywhere. It was there the whole time, but again, we were ignoring it because of the order of operations stuff. But now it's a good time to show it because we need that denominator to operate at this point. So I'm going to rewrite this as a division problem. I think that would be easier. That's going to be 2 divided by, because that's the fraction line, -2, okay? Which, when I combine, I know it's going to be negative because of the opposite signs, and then 2 divided by 2 is 1. Done. True. So 4b, parentheses, b minus a, right? And remember, there is multiplication between the 4 and b and between the 2 sets of parentheses right there. So let's go ahead and do this, but I'm going to replace, I'll show this a little differently. So the a's are going to be 2, right? So that I replace this a with a 2. And there's my parentheses, and the b's are going to be replaced with 3. So there's a b, I'll replace it with 3, and I'll replace this b with 3 as well. Okay, everything else we need to see. So that's 4 parentheses, 3, and that's out of parentheses, and then the other one is 3 minus 2. Now, again, I always just start with the one on the left. I don't really care where you start. Just make sure you evaluate these by parentheses. So parentheses 4 times 3, which is 12. And then in this set of parentheses, that's 3 minus 2, which is 1. Okay, so that set of parentheses ends up producing a 1. 12 times 1, not too bad. That's just 12. Done. All right, how about this one? Again, I'll just do this one just like we did before. I'll rewrite it, x to the power of 2 plus parentheses x plus x minus y. And then I'm going to replace all the letters with the numbers they give us. So x is -1. So replace 1, 2, 3 different x's there with -1. And then the corresponding y value here is 3. So I replace the y value with 3. Then I just evaluate. So in this set of parentheses, I got negative 1 to the power of 2, which would show as negative 1 times negative 1, which is positive 1. Now the other set of parentheses here, so that'd be negative 1. Again, there's no parentheses, no exponents, no multiplication, division, just the addition and subtraction. The addition's first because it's first on the left. Negative 1 plus negative 1, it's just going to make it more negative. 1 plus 1 is 2. Now I can subtract that 3, which we don't really need the parentheses for, but it's a subtraction with a negative. So I'll use keep, change, change on that. Change, change. Now it's negative 2 plus negative 3, which is going to combine to make that more negative. 2 plus 3 is 5. Okay, so I end up with 1 plus negative 5. I see now when I go to combine these that there's more negatives than positives, so the answer is negative. 5 minus 1 is 4. That's how negative it is, negative 4. Done. There's a word problem right here. The expression 15 plus 8G can be used to find the total cost in dollars of bowling, where G is the number of games bowled, and 15 represents the cost of shoe rental. How much will it cost Stuart to bowl 6 games? Well, I'm going to use the formula on this one, although I think some of you could probably figure that out on your own. So the formula they gave us, or the expression, 15 plus 8G. And right over here they said that old Stewie is going to bowl 6 games, right? So I'm going to replace G with 6 right here. And just evaluate. So order of operations, again, please do not do 15 plus 8. Don't do that first if you're going to use the formula. We're going to have to do 8 times 6 first. That's 48. So I end up with 15 plus 48, which I'll stack and add. So 48 plus 15. 8 plus 5 is 13. Carry the 1. 1 plus 4 is 5 plus 1 is 6. So I end up with 63. Now, the answer to this is not 63. Because it's a word problem, it's actually $63. Okay, don't forget your labels on these word type problems. The next question, how much does each game of bowling cost? You can kind of use the process of elimination on this one, because in the formula they only gave us 15, 8, and G. Now we know the 15 represents the cost of shoe rental, so it's not 15. It's the shoes. The G is the number of games bowled. Now down here it says it wants to know how much it costs for each game. This is just how many games bowled, so it's not the G, it has to be the 8. So the answer here is 8, but again, it's not just 8, it's $8 per game. Or for each game, however you want to word that yourself, but $8 per game is good. Now another way you could have recognized that is because it was the number of games times whatever number that is. That will be your rate for each game, or how much it would cost for each game. That's another way to tell. Okay, there's our 2 objectives, hopefully now. And yeah, we did do some absolute values, which we combined with the order of operations. But 2 objectives, I can use the order of operations to evaluate expressions, which really is just order of operations stuff, and even replacing letters with numbers to evaluate. Still more order of operations stuff, with just a tiny little extra step there, but no extra calculating involved, just extra work.